Hello everyone. Now we are going to see the new update on Mocap MPP2SOS. After 7 hours of coding, I was able to release this version 0.03. We are going to test on the newest Blender release 3.2. Here you got some links to previous videos on another project where this UI was based on, which is CEB Mocap, Easy Mocap. Now here we can create a project using the settings we're going to use for the cameras. In this case I'm going to use 2 cameras, this resolution, 60 FPS. These settings doesn't affect the add-on. It's just an information for you what information you are storing for the calibration. And we gonna name this YouTube 1. Create setup, and it creates this information, which is a folder to store the calibration data. We have to set the project folder, which is going to be here. I'm going to create YouTube 1. Open this folder and set the project to that place. And it goes automatically to the Intrinsic Calibration. You can import from another project if you have. I don't have another one, and if I choose the same, it's going to say to me you have to choose another project because it can't copy to itself. So let's go to the Intrinsic Calibration. Here you have the list of cameras, so you got to choose the calibration data. In this case I have here in Intrinsic Calibration videos, and next camera, set that one too. Save video, it's gonna copy the video to your project folder. 3D to VSC, so we can see the video and choose where the important parts of the video to calibrate. So I click this, open this view. I'm gonna go to the camera one, load it here. And the important part, we must use M on the sequence editor to choose the important frames that we are going to use. In this case, I try to get the corner of the image, the chessboard, when it is in the corner of the images. So here, this one is interesting. I press M. It's going to create a marker. I'll choose here and here, always pressing M. This angled one, so you can detect the deformation of the lens to calibrate it. And I think that's fine. I selected those frames and then I press render frames, so it's going to get those frames for calibration. I'll go to the next camera, clear markers, because the place where I'm gonna choose are mostly different from the camera one. Load the video, and I'm gonna look where are the places that are important for me. One corner, press M, another corner, press M, press M, M. Let me see if I recorded another interesting place. Press M, 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 and M. And one for the final one. Render frames, and that's fine here. This pattern is the amount of intersections you get on your chessboard. In this case, I am using a 3x5, which means 1, 2, 3 by 1, 2, 3, 4, 5. That's the amount of intersections. This is the size of the square in millimeters, I think. I had this already, so I didn't change. Now you press detect chessboard, and it's gonna take some time to to do the detection. And now I remember that I forgot to open the console so we can see how the process is happening behind the scenes, because we don't have something to show in Blender yet. I'm gonna pause the video because this part takes a little bit, and I'll be back as soon as it finishes. And didn't take that much, it finished. Let me open the system console so we can see what's happening. Let me change the size. Okay, so we just did the intrinsic calibration, detect the chessboard. We must press calibrate, it calibrated, and save to the project, I think. I don't remember now. We go to the next part, that is the extrinsic calibration. We gotta set the videos we're going to use. The camera 1 is going to be, let me hide this. It's going to be YouTube, synced videos, walk. First camera will be this one. The second camera is going to be this one. And we're gonna save the video to the project folder. I already have this split view with the 3D view and the sequence editor, but I can press again, it won't affect. Now we are going to do almost the same thing done in the intrinsic video. We are going to select the place. In this case, we're going to select the place where we can see the chessboard to do the extrinsic calibration. Let me clear the markers. We are not going to use it. Let me go to the beginning of the video and load the first video. We can see here the chessboard can be seen with no problem. So I press M here to select this frame for render and render it. I'll go to the next camera, load it, and I can see that on this frame that I have already marked, I can also see it without a problem. So I'll render it too. So we have frames from the first and the second camera that we will be using to calibrate the camera extrinsically, which means to know where in the 3D space the camera is pointing, so we can detect correctly the pose. So we've done this part. We're going to detect the chessboard. It finished, calibrate, and now we're going to check how the calibration is. My chessboard is very small, so it usually gets not very good calibration. Let's see. Check cross. It went well on this first one, but the second one not so much. Right. Check the cube where it projects a cube on the chessboard. It didn't go well. So we see that we must do some fixing to use this calibration data. What we do, we must use label me. That's the easiest way that I found. You can install it using Python. Usually the install is pip after you have Python installed on your machine. Pip install label me. I already have it installed, so I'll just use the command to open label me. And here I open that. This part is a little bit tricky, confusing, I must say. You go to the project, extrinsic video. Here we're going to choose the image that we selected to the extrinsic calibration. We go to the image, camera 1, and we have just this frame, select it. I like to zoom 300% so I can really zoom it very well. Create polygons. So important thing here too, you have to manually calibrate. If you have to manually calibrate like I'm doing, you have to choose always the same direction. See that I'm going to start here, so I go doing this, and this, and end here. So I'll start here and end here. The other image will have to do the same thing. Let's go then. And press enter, select any name, it doesn't matter. Okay, save. It's going to the same folder that you loaded the image, so just press save and open the other image. Folder 2, this image, let's zoom and go to the chessboard. Select create polygons. Remember that I told I started here and ended here, so in this one we're gonna also start here. If you don't start on the same place, I think you get the flipped result. I'm not sure. Okay, and save. It's already on the same folder of the image. Press save and you can close it. Now you must update the data to use this one that we just did. So we have this menu fix JSON, and we go to the camera one. That's the original calibration data that we are going to overwrite with the correct one that we just did manually. So set the origin, which is Mocap, in my case, Extrinsic, chessboard, and camera 1. Select this JSON, and the correct one is, remember, the one in the image folder, X3 image 1 JSON. Press fix and the file is updated. Now let's go to the second camera. Let's choose the origin. It's already near where we want. You just have to change to the second folder, which means the second camera. And the correct one to image 1, we have to go to the folder 2, then select the JSON, fix, calibration. Now we are going to see how it went now. And you see the crosses are much closer to the correct point. And the cube, you can see, makes much more sense. So the intrinsic and extrinsic calibration is done. Now we are going to the final part, and by this time you already have the intrinsic and extrinsic data saved on your project file folder. Let me show. It's in this folder 0 calib entry. We have that folder with the same name we just created. You can see here. And inside it we have the extrinsic and intrinsic calibration we just created. Now, after creating it, we are going to convert. If you create another project and want to use, if you don't go through the steps of intrinsic and extrinsic calibration because you're using another project, you must press this button to import, or the rest of the process won't work. But we did the intrinsic and extrinsic, so we just go to the convert. And you see here, oh, not here, sorry. The convert goes to the project folder where you are using, in this case, YouTube 1 and Calib 2D. Here is the converted file you see created just now. And now we go to the convert video, which is going to be converted using media pipe that comes bundled with the add-on. And here you can see the process. As we have two cameras, we can see how is the process here too. Post 2D, he's going to create one folder for each camera. You can see we just have the camera 1, and it is creating the post data. Soon it's going to start to create the second camera. It takes a little bit. Obviously, it depends on the size of the image, the video that you use. And while it's doing its job of conversion, let me show another thing. One cool thing I like to do is split the videos in part. Instead of recording and converting a full 3-minute video, I try to convert like this. I take a full video and I grab some actions that I found that I wanted most. So I sync and split it by action. So you won't spend too much time converting the actions to motion, the videos to motion. And you don't have to calibrate everything again, because you can do the import from another project, which makes the process much faster. It's almost finishing. Let's wait a little bit. And you will have to do after this is pressing sequentially these options. Copy the config file. It's gonna prepare for the use of post to scene. Now the conversion is done, so we can finish. Copy config file, track to the. I think I didn't press. What happened? The file is here. Oh crap. I'm gonna try to find the bug and continue after it. Bye bye. Just found the bug, fix it and upload it. Now let's continue. We have converted the video. Let me show the folder. We got a copy config file, which is going to copy a user and this file, if I'm not wrong. Track 2D is gonna make an open pose process, and it just did. Triangulate, we're gonna use data from all the cameras and use the calibration data to make a 3D representation of the points. Filter, it's gonna remove some crap that happens when we use pose estimation. And process open config file. I'm gonna set up every file necessary to be processed in OpenScene, and we run OpenScene, which is gonna run the solvers inside it to make a much better animation. It shouldn't take long. I think it's 9 seconds of animation. And there is an important thing to consider. At this moment, this add-on is making the movement inside of Blender, translating the movement inside of Blender using position points. The best is use angle, but I wasn't able to figure it out yet to properly use angles inside Blender from OpenSea inside Blender. So I'm using location data. So after run OpenScene and we use import option, one important thing is needed to be considered. Maybe the location data might be a little bit off from the skeleton. In my case, it's fine because I did a lot of tests. But if the position is a little bit off, you might want to edit the bone to increase its size so it can match better the position points. You can use the length to increase it and so on. And after everything is alright and you see that the movement is the way you want, it's matching the position empties, you can press the finalize, which is gonna remove, which will bake the animation and will remove the empties. So for me it's good. Let's just see how is the animation. It's not the best one because it's using two cameras. I didn't use a proper location, didn't record it very well, so it's kind of janky. But it's fine to me and to show you guys how it works. So I'm gonna press finalize, which will bake the animation and remove a lot of things, and we're left with only the armature with the animation. And here it is. Hope you enjoy it. See you next time.